So, morning to everybody. So first of all, thank you to invite me here. It's a pleasure. Even if I'm a little bit out, I'm on up and inside, but it's a pleasure to be here in the Alps. It's beautiful Alps. Okay. So our region, in our region, a relevant flash flood took place almost 2 months ago. And it was caused by a persistent bush-shaped thunderstorm in the northern part of the region. It's on the left, you can see the VMI product from the radar mosaic. This bush-shape just was born in Tuscany, then passed Umbria and reinforced and stayed stationary in the northern part, northern center part of our region. Here you can see the precipitation maps is emerging between radar and rain gauges. So this V-shape made a high precipitation in all this area. It involved many small basin and sub-basin that are in these areas. The amount of precipitation was really relevant. It is a kind of event that never happened in our region, at least many years. Looking at the rain gauges network, this is our station in our region. We have an amount, a really high amount of 400 millimeter. And the amazing part that's just, daily is just a high amount of precipitation in our region. But what's amazing was the concentration of the precipitation. The precipitation just happens in almost in 6 hours. So we have from 4 p.m. to 10 p.m. we have these large, more than 200 millimeters in 3 hours in that part, and it was always persistent in that area, especially here in Cantiano in Burano River. So, which were the effects of this extreme event? Looking at the return time analysis, I know this is a little bit old-fashioned analysis, but anyway, gives an idea how much this event was outside our normal historical data set. So especially the 6 hours were, completely out of normal time series in return time. We estimate a return time more than 1,000 years. I couldn't put here like 3,000 because it was completely outside our climatology, but that means that it was really an extreme event. It never happened in our climatology. And also there was really relevant is also the intensity of the precipitation, more than 10 millimeters per minute. So really a strong intensity on that area and concentrated mainly in 6-8 hours. Another important fact that the hourly aerial average rainfall on this small basin was really important. You can see here the millimeters, the hourly millimeters. And the precipitation, the duration was really close to the concentration time of the basin. So for the basin was the worst precipitation that could happen, especially here on the sub-basin Burano of Metauro Basin, the Cesano River, and Misa Basin, and also Sentino, there is a sub-basin of Esino River. So on this basin and sub-basin, the response of the river was really quickly, really fast. You can see how steep are the hydrograph. This is a Burano watershed, the Cesano watershed, the station, the water level station that we have on the main river here in the Sino and in Misa. Just to have a look at once for explain better how fast it was. This is a Bettolelle water station. This is a station that is just before the Senigallia town in Misa Basin. And from 9 p.m. to 10 p.m., 10:30 p.m., in almost 2 hours, we have an increase of the water level of 5.43 meters. That in terms of flow, we pass from almost 1 meter cube per second to like almost more than 500 meter cube per second. And this is a small basin, so it's a really huge amount. But what was amazing also was how fast it passed from, our green thresholds, our alert thresholds, to the red one. It just in half an hour. So the time for giving an alert was really, really short. And especially, in the first hour, we passed from 1 meter to 4 meters. That it means, for almost 1 meter cube per second, still 200 meter cube per second. So it was really, really fast, especially the first part. You see how is the slope. So that's happened not only in Misa, but also in all the other basins that I introduced before. And that's the flooded area in Misa Basin. I show you the Misa because here, unfortunately, we have also a lot of victims. But we have flooded area also, a relevant flooded area also in the other sub-basin. And that's the picture of in Senigallia town in the night. So it flooded in all the town. And that is the hydrogram just here in the center. So here's some picture of the effect of this. What was important to underline that there is a lot of solid transport, and the effect of the secondary network was really important. In this event, all the secondary and primary network was involved. We have a lot of erosion. The bank were completely changed after this event. And many bridges in the main river and in the tributaries were completely destroyed from this event. You can see all the force of water. So it was really, a flash flood that completely, devastated all this part of the territory. And the solid transport was really, really huge. This is one of our stations that was completely, covered by solid transport. And for example, also here we had a water station that was completely, destroyed by the flood. We just recorded, a green threshold level, and after a second, the water station was completely, destroyed from the flash flood. So it was just in real time. It is other picture in Cantiano in Burano River. They had, many damages. This colleague is really tall, so we had really relevant events. Well, just I show you what happens. So just start from the day before or the same day. What was the forecast? Well, unfortunately, this was an event where we couldn't forecast. I put here the average rainfall forecast on our alert area. I know this is a simplification. It's just we don't have a look only at precipitation field, of course, when we do forecasts, but just to underline, especially also how low both the global numerical model and the limited area model. So these events. This is, for example, the run, the 15, well, the same day, the event happened in the afternoon. It is the run at 00 and 12 of the same days. This is the run of ACMWF model. So you can see the precipitation field that was forecast was really lower, both in the run. At what in reality happened is the precipitation of the observed precipitation in all the 3 areas, 1, 2, and 3, where 1, 3, and 4, sorry, 1, 3, and 4, where the main precipitation happens and where I saw you, the main effect. And another thing to underline that we came from a relevant summer drought period. Our basin, there is a small basin, that just go in the Adriatic Sea. We're really dry. We almost have no water on the river. In fact, we have many problems with drought. And before the event, you know, this is the map of soil moisture condition by ASCAT. You show you a really dry soil moisture. So the main effect were also caused by that, because the first hour the water couldn't infiltrate properly, and so there is also a lot of solid transport on the soil. So we had flood and landslide model that help us during the forecast, but of course, as we don't have the input of precipitation, they couldn't help us to forecast these events. So our alert bulletin the day before, and also the day in which we had the event, was just, you know, a yellow alert for thunderstorm in 1 and 3, because our meteorologists just saw something, you know, the clue that we could have some heavy thunderstorm that could pass from Umbria region, but you know, we didn't expect an event so extreme. Our hydrological model, of course, with observed data, with this such amount of precipitation, so the criticality, of course, but you know, especially this model is a flood-proof chain that we use also for monitoring real time, give us you know, an output every hour. But, you know, the timing of the running of the model with observed data each hour was almost, you know, the output was almost in real time when the event happened. So it couldn't help also during the monitoring phase, because it was so fast that it was really difficult to, you know, to monitoring what's happening in real time and do a little bit of nowcasting. If you want more information about this event, so 50 minutes is not a long time, we publish online our preliminary report, and also thanks also to an ordinance of civil protection, we are, you know, studying more in detail the event, and I know that there are, you know, many national projects that are working on that, so it's becoming a national case study, unfortunately for our region, but it was really a relevant event. So what we learned from this event, at least from as forecast center, we realized that we have still a high limit of forecasts of these extreme events. So you will know better than me. So I'm curious also to listen to your presentation if you have a new product that could support our center. So we need to work a lot still on this side. And on monitoring phase, well, also the monitoring phase, we need to work a lot about that, because because we need to improve nowcasting product that could help us. Meteor radar program, nowcasting meteor radar product, faster hydrological model run, simplified hydrological run that could give you the output just in few minutes, so they could support also with observed data in real time. And I think we need to increase also the number of specialized persons that work in a functional center, because we are still few people that work on this center. And with this fast event, we need to be more and really well prepared, well formed. So I hope that also in the educational field, there will be more young people prepared to manage this kind of event. I think we need to improve also the tools to alert municipality, population in real time, and on national level, there is the IT alerts. I think everybody knows here what will be. Probably on local side, we need to also to produce other tools that could support the municipality to alert the population. And we are trying to update also our operative procedure to be updated to the climate change, because we need to add, for example, precipitation thresholds during the event to alert the population in real time. But what I think is more important also with this extreme event is to educate the population, the municipality, to have civil protection system that works more in coordination, because the time is so few, it's so short that people must be aware of what's going on. Many victims that we have on Misa Basin was because they didn't went to on the second floor, they went outside to move the cars. So we can, enhance our capability to prevent this event, to nowcast this event, but if the population always, the behavioral population will be always wrong, we couldn't, help in a good way. So I think civil protection must work a lot on that. We were already working on that also with the STREAM project, the Interreg Italia Creation project on all these points, but nature was faster than us. So I think we need to, to work more and quicker on that side. And the last, I put also this last point, after this event, especially when there are victims, of course, there is a prosecution investigation. Well, we were all involved in that, so I think we need to enforce also the operative procedure for our poor forecast officer, because, it's not nice to be involved also in a prosecution when you are also only doing your job. So I think we need to work also on that side. For me, it's all. I hope to be enough clear. So if you have questions, please.
So thank you very much, Francesca. Is there any question, either from the audience or from online? If not, we can anyway. Oh, please.
Okay, Gianni Marigo, ARPA Veneto, Avalanche Center of Araba, and coordinator of the Weather Forecast Office of Teolo, of the Regional Center of Teolo. Two consideration, they're really difficult to well predict intense forecast, either for intense thunderstorm, either thunderstorm really impossible with this kind of models. And second consideration, I think that the most critical phase remain how to transfer real-time or nowcasting information to the population. Okay, everybody in a civil protection center can see an extreme event occurring, but it's quite impossible at now in Italy to transfer a correct and really good information to the population.
Well, it's not really a question, but I agree with that, and I underline also that, because the main problem was that to be in time to inform the population, to inform the municipality, and to react, because also the operative room has a lot of problem to do, especially when the event is so spread in an area that is, it's involved many basins, many sub-basins, so the territory was large. So this is the main problem now, I think. I agree.
Thank you very much for your comment. Later on in the morning, we will have also a panel.